my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage. Okay, so next up for us is we're going to get the workpiece put down to the machine. I'm going to get the machine turned on, and I'm going to get our mounting posts put down on the table. I'm going to determine where that place is going to be, and I'll move the vectors in a spire to the appropriate place. I won't video any of that stuff, and probably just going to pick up when we're starting to cut material. One thing that I do want to show you before I do that is I've added a couple of cold air guns, X-Air. These are the 5240s. I don't remember the part number. This is what's qualified as the high power single outlet style. I actually have two of them on the machine. I only use one of them usually, but I'm in development of this idea because what's happening is a lot of the aluminum I'm doing is slotting. So imagine if all we're doing, like what we're going to do on the aluminum here, imagine if all we're doing is just cutting that pocket or that bevel back and forth. Okay, that's all we're doing. We're just cutting it back and forth. Well, it's okay to have that tip of that cold air gun pointed like right in the back here. If I were to take the cold air gun and just imagine it was doing that. That's fine because we're only moving in this way, but in that linear direction. But what I didn't love was when we were cutting the hand wheels, these round objects. What's really happening on this? Well, you can probably start to see what I'm talking about. We're moving around. Well, my cold air gun, if the camera perspective is the tip of the nozzle, we're getting a lot of cold air hitting it, but not so much over here. Not so much. Oh yeah, we got some air hitting it now. Well, not so much over here. Not so much. And I realize that we're probably cycling air around that pretty well. At the end of the day, you know, it's a blind spot. Is just the bottom line. And it takes a lot of air to power these things. And I'm in the process of learning about the science of this, of how much air that you need. I've substantially increased the capacity of air on hand. I have done the best I can with consumer level sort of compressors for CFM, and I can blast 40 PSI coming out of this alone. I can actually blast more than that, but for sure 40 is no problem. And that's generally between 35 and 45 is what I'm hitting the tool, and it's keeping the tool nice and sharp. I'm not atomizing anything. You know, I've got the ability to puff lubricant. I don't want that hanging in the environment. The cold air is working, is what I'm trying to say, so I'm really happy with how that's working out. I added a very small, up to 60 PSI pressure gauge right here so I can see it. I've got my on-off right here. So I'm really thrilled with that. So, okay, I'm gonna get this fixture down, gonna monkey around with that for a little bit of time, and let's just, hopefully we're gonna pick this up when we're cutting stuff, so let's do it. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, so what I've been able to do is to get the part placed down and clamped down, and all that I've done is I have positioned my end mill on the workpiece, over the workpiece, and I've established what this point is. I've established what that point is, and how I've done that is simply in the SB3 software, just hit K for calculator, and I've manually moved the spindle to where I know that I can secure the workpiece down to the table. Then all I'm going to do in the software is move my vector to that XY coordinate, and we should be good to go. So let's move on. And let's take a look and see what happens on this. Heaven help us. Here we go. out what the problem is. Let's take a look at our tool path and see what happened. I think the issue is going to be is that we are on that's correct. What I'm thinking is that we're just not in the right location. I told it 4-inch, but the workpiece is actually 4 1/8. Our workpiece is not where I thought it was going to be. That's the entire issue. Our workpiece, this corner I had at 4-inch on the X and 28 on the Y. It's actually at 4 1/8 and 28 3/16. So I'm going to reposition it in a spire, and then we'll fire this up again and see how we're doing. So I've repositioned the workpiece, and how could that have been avoided? Well, it could have been avoided by me double checking, because the workpiece is clearly not in the right area. And what makes it marginally ridiculous is because, as you know, I only have this one piece. Now, I'm not overly concerned about having a little bit of the backside of this prototype mounting post a little weird, but I am happy with the feed rate, which I have at about 0.67 inch, 7,750 RPM, inches per second, 0.67, 0026 on the chip load. I found that I felt good with the bit working through the piece as we were watching it. So, double checking, just an inexcusable error on my part, and I have to get better at that. And in the spirit of getting better at it, let's actually double check. 4 1/8. Yep. A half, yeah, because I've got a little bit of I've got a lip of this material over here. So it should be good. Let's get the tool started actually and see what happens. Let's hit the spindle. One thing I'm going to do with Chris Burns when he gets here is I'm going to put up some sort of a visual indicator when I know the spindle is running, because I'm forever concerned, oh gosh, did I push the start button all the way? No, yeah. Yes, this is how I want this. I want to be rotating in a clockwise direction. Rotating in a clockwise direction because we're using an upcut. I want to pull away from the work as we cut it. Happy with the feed rate. I'm happy with the chip load. It looks like it's nice. What I want to do is pause the tool path to put the dust food on so that it's just going everywhere. With that now, bring cold air going, sneak it inside again. So I'm just going to let this run now. when we get really down into the deepest part of this, we're probably going to get a little more involved in what's happening, because I got that really small piece right there, really small. We got to be really mindful of what we're doing on this. So I'm going to let this run. I'll let the camera run.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, so we've gotten pretty deep into it. So I'm going to pause what we're working on, and I want to take a look and see what the tabbing looks like, because we're within 60 thousandths of being done. So let's hit the space bar. Let's just keep rolling is what we're going to do. Okay. All right, so I think we're okay. What broke was that big piece that was there, but I don't think it hit anything. I don't think anything came loose. The end mill looks okay. That's what broke loose. My concern is that we're not in the same position that we used to be. Yeah, it looks like we are actually. So, assuming our piece didn't move, which I don't think it did, because I've got 4 of these clamps on here, and they feel reasonably tight. Let me put the tape measure on our length. See if I can judge that to a certain extent. I think we're okay. Yeah, I believe that we're okay. The end mill feels okay, but not as razor sharp as I would have expected it to be. I'm trying that SGS bit on this, and I'm just have to see. So what we're going to do is we're going to restart it, and hopefully we don't hear a lot of contact when we come down. It doesn't look like we've moved though. So if we haven't, then the moral of the story is we know we can't leave those tiny artifacts because they're going to break loose, and the bottom line is we won't if we go to production on this. We won't leave any small pieces. Everything will be connected on a skeleton of connected pieces. So that's good. Yeah, we moved. We definitely moved. That's a shame. Let's, what happened? Let's pull this off and see if we can salvage anything. Well, you know, I can't explain why it jumped over like that. But, you know, it appears as if we've got one good mounting bracket here. Well, reasonably good. Let's see if we can get that off the workpiece. So, do a little bit of housekeeping on the spindle, and let's move it out of the way. Something wasn't right here. I have a feeling that we lost our Z-axis for some reason, because it plunged down way into the plastic that it's glued to. Way in, way in.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.